What we want to do today is just go through the basic installation, i.e. what we have here. We're going to install something called the Jupyter Lab IDE. Now, before we even get into it, there are terms in this presentation that may sound funky. Don't worry about it. When you hear the word, for example, IDE, just think of it this way. This is a shell that lets you code and lets you see the results fairly quickly. That's all that it is. Jupyter Lab, Python, all of these things are free. That's the other cool part. Almost every industry, I don't care if you are in, for example, McDonald's uses Python. AAA finally got onto Python. My old place, Virtu, I pushed them to go to Python before I left. Python is universal, and it has the ability of doing pretty much anything and everything. When we think of Python itself, this is why I like to call it. It's this high-level programming language. It could be used for anything. Now, what it does, unlike, for example, Stata or SAS, is that Python utilizes libraries or packages. So I like to use this as the classic example. We've all taken stats, and in some cases, it gave us acid reflux disease. You know, remembering, how do I calculate standard deviation? How the heck do I calculate a z-score? We've all been there. Well, Python has packages that all I have to do is throw the data at it, gives me the results right back. Done. And it also has the ability of merging data, slicing data. That's the big thing that has over Excel. Excel, it's one giant table, and if you want to cut, you have to either create a pivot table, you have to cut, paste, do all of these things, make sure you remember what you've done. With Python, it shows every single step. And that's the thing that we're going to do today. We're going to go through some of this stuff. What we're going to be playing with Python, and not with this specific session, but starting next semester, we are going to utilize things that we would do, for example, in a forecasting class, things that you would probably do in a graduate class, where we could connect with an Excel file, where we could connect with a SQL database, Java, R, doesn't matter. We have the ability of connecting. And B.E.St has decided this semester to work with census data. This is where all of you that are on, I highly, highly recommend and hope that you guys talk with the members of, or the best officers to say, hey, what you want to see. Now, here's the other thing before we even get into it. This right here, all right, this are the direct pathways or the URLs for Python. We have it for Mac, we have it for Windows. Now, typically speaking, the majority of individuals in the academic world and the private sector tend to have Windows-based machines. The instructions here are more Windows-based. However, I checked it out. I have a Mac, I played with it. It's the same process. It's a little easier than the Windows, okay? When we click on python.org, it's going to take you to a specific website. And what I recommend is always use the executable installer, or at minimum, the web-based. Don't do the zip, all right? Typically, we'll have to compile it. Why give ourselves some headache, okay? I always use the 64, that's just because for a 64-bit machine, most of your laptops will use that one. One thing to note, if you have Windows 7 or earlier, 3.9 won't work. You have to go down to 3.8. Not a big difference. It's just a couple of extra stability features, but there's nothing wrong with it. I like to liken it to the following. The difference between a first edition book and a second edition book is just the bloody cover. That's it. Okay. Once we go to there, just like before, and again, this is where it's going to be, and I apologize if it looks mundane, just install. Now, here's the key thing that all of you should do. Make sure that you click this box, Add Python 3.9 to Path. Here's the reason for it. Python utilizes a lot of what we call CPU and GPU, what is it called? CPU and GPU meshes or thresholds. A lot of the calculations are done against a CPU processor versus just your hard drive. It makes things a little faster. I'm not going to get into even the nitty-gritty of it, okay? Once you install it, all you have to do, okay, is go to your Start Windows, all right? What would happen is something like this, where you would type in CMD, like so. And when this happens, this DOS prompt will, pop open. All you need to do is type in Python and hit the Enter key. So it'll be like this. What this will do is it will put you into the Python, what we call subroutine. All we need to do, or the Python environment. Don't worry about it. It's just to make sure that Python was installed correctly. You could get out of this by typing in exit, open paren, close paren. Hit enter, and it'll take you back to DOS. If you want to exit DOS, which I fully recommend to everyone, just type in exit one more time or click the little X. Perfectly fine. This screen will pop up when we play with Jupyter. Again, it's just a processor. It sits there. Okay. Before I go on, are we comfy with it? Everyone okay? Just at least with the concepts? Okay, cool. Awesome. Now, once you have that, like I said, Python, here's the thing that I was talking about. You have everything on, everything is gold. Okay. Now, let's install the Jupyter software. Okay. Here's the thing about Jupyter. Jupyter is unique to what we would call other IDEs. Some of you may have taken a class with R, and you probably use RStudio. This is similar to RStudio, but with one minor and very significant difference. You code through a web browser. Chrome or Firefox are best. Me personally, I find that Firefox is more stable than Chrome, but to each their own. If you have a Mac, Safari is perfectly fine with it, okay? Now what happens is the following. Once you open up Jupyter or Jupyter Lab, you're going to see that window that I showed you earlier where I typed in Python and then we loaded that screen. Just leave it open, all right? It's not a big deal. What it does is this is that what we call a restful state. In other words, it's waiting for us to open, or execute a command, okay? Now, there are a lot of different ways to install Jupyter. There are two very common ones. One is through what they call the Anaconda system, and the other one is through Python's root directory or root command. Now, me personally, I love the root command, but some people are really uncomfortable with it, and that's fine. Anaconda is the piece of software that we're going to be using. It's a package manager. What the heck does that mean? What it does is the following. is that anytime there's an update, the Anaconda system will refresh everything for you. You don't have to run around and install packages in the back end, etc. It's just it's easier. Okay. And here's we have some documentation. I have it here for you also. And again, Windows, click this. Mac, click this. If you want to use Python's pip command, I have it in there, but I recommend, especially if you're very new to coding, stick with Jupyter, okay? When we go through the Jupyter command, and here again, I'm using the Windows base. Same though with Mac. You're going to see a couple of things. You're going to install one of these guides. It gives you everything that you need to do. Select the Anaconda installer. Okay, don't use Miniconda. That's typically used for more like mobile devices or smaller instances. I like personally Anaconda installer. It's just less of a headache. Once you get there, once you click one of these links, it's going to take you to what they call the individual edition installer. That's the freeware. That's what we want. Okay, click download, select your OS. As you see here, we have Windows, we have Mac, and for those of you that are really hardcore, we have Linux. Okay. Not an issue. Once you click on these, and again, I'm using 64-bit. Most machines nowadays are 64-bit. You're going to go into this screen, and you're just going to click. Now, here's the thing. I always say, unless you have to share your machine with friends, family, all that stuff, if it's just you, just click just me. Otherwise, all users, it'll just be easier. Throw in your destination folder like any piece of software. But here's the thing. What I want you to do is keep this one, register Anaconda 3 as my default Python 3.8 user. Don't do the path. The reason for this is that if, for example, there's a problem, if Anaconda, the software itself, if there's a big bug, that's not our fault, but the Anaconda developers, it's a pain to uninstall. A lot of nitty-gritty stuff that we have to do. So keep the register Anaconda 3 as your default. Okay. Once you have it, we're just going to confirm. All you need to do, as I said earlier, or as I did with the Python, is go to your Windows button and just type in Anaconda. Here you go. It's going to take you to another prompt. This again is just to check to see if you have everything. Okay. What I recommend that everyone do once Anaconda is loaded, okay, is type in the following. It's going to be install -c Conda Forge Jupyter Lab. What this does is the following. It's saying install a stable version, the complete version of Conda. This is a command that's going to go out into the Anaconda directory on their website, not ours, okay? And it's going to install the latest version of Jupyter Lab. Sometimes you're going to see, hey, we have something new. It's always a good idea to run this at least once a quarter. Now, here's the thing. For me, I already installed it, so I don't have to worry about it, okay? Now, what we're also going to do, get rid of this is what you're going to be seeing, okay? Now, if you want to be more intense in terms of pip, I'm going to leave this here for you. Louis, I think you used pip, right, for this, or
yeah.
Okay, so you could use this also. It's perfectly fine. It's a little more old school. It's fun. I'm going to geek out every so often with it, but you could definitely play with this one. Okay, now let's run Jupyter. okay? And let's start looking at some of the things that we're going to be playing with, okay? So first up, let me cancel out of this, okay? And let's run Jupyter and go through some of the basic structures of Python, okay? Now, when this is going to open up, you're going to see here's Jupyter. It's going to look, it's going to take a little bit. What it's doing is building our environment, okay? Come on, okay. Now, what it's going to do, it's ask you, okay, initially if you want to use Firefox or have it built already for Firefox, okay? And this is more or less what you are going to see. Move you out over here, okay? Now, before I even go on, is everyone okay? Are we comfy with what we're seeing thus far? At least the concept-wise, etc.
I had a question. Where do we go to install Jupyter again? What was the web?
Sure, not a problem. Let me load it up here. So Jupyter, let me send, you know what? Let me put it into the chat so everyone can play around with it.
Yes, please.
Oh yeah, no worries. Not a problem. Not a problem. So this is Jupyter. Where are you, Jupyter? Here we go. Through. Okay, you got so let's go through it. So you know what? Let's go through the Jupyter install. Okay, I had a couple of questions. So we're gonna go here. It's gonna open this section.
Yes.
Okay, everyone see that? We good so far? Anything? Yeah, okay, cool. So you're gonna click on Anaconda installer. In this case, I'm doing it for a Windows machine. When you click on this, okay, to the Anaconda download website. One is, again, it's just a URL, etc. You're going to click on download. What it's actually going to do, it's just going to take you all the way down to the bottom. Okay. And click on the graphical, again, depending on your machine. Most machines are 64-bit. You're going to click on this sucker. Okay. What it's going to do is you save the file, all right? And it will take you to, this will download into your downloads directory. If you have Firefox, if you click on this little downward arrow, it'll say show all downloads, okay? And once this is done, and depending on your upload speeds, etc., since we're recording and we're also streaming and all that stuff, mine's a little slow right now, but it's about a 400, 500 meg file, okay? So we should have had the Jeopardy theme song in the background for it, just in case. There we go.
Do we have to create an account with Anaconda?
No, we don't. That's the beauty of Anaconda, is that it is all of these like Python, R, Anaconda, Miniconda, it's all open source. That's why they became so popular, because Python was actually written by a mathematician who got tired of using SAS and Stata because it was so expensive. So he built Python and he made it open source, just like R. So you don't have to register or anything. Okay. So once you click on this, all right, it's going to open the installer. Okay. When it opens the installer, okay, it's going to take you here. Okay. Uh, yeah, you should. Louis, can you send the deck to everyone or the PPT if you would? So, and you will click. But before, is everyone okay? Are we comfy at this point? Yay, nay?
Yeah.
Yeah. Okay. Cool. So you're gonna click next. All right. Always click I agree. Don't worry, it's nothing like the South Park episode with the iPad or iPod. And then once you click agree, it's going to say install. Now, this is where I was saying, if you're the primary user, or then, in other words, you don't have to share your machine with anyone, just say just me. If you have siblings or something like that, and you want to keep everything more private, you click all users. All right, just make sure that you have admin privileges for your machine. Okay. When you click, after that, you click next, and you install it in whatever directory that you wish. This would be the default. Okay. Me personally, I have my own little server that I put it on. So, but this is what you would do. Okay. Once you click next after this, it's going to say add Anaconda to my path or register Anaconda as my default. Just leave this, okay? And then you're going to click install. Okay. I'm going to cancel out of this because I have it, okay? Are we good so far? Does that answer? Is everyone more caught up or comfy with it?
Yes.
Yeah?
Thank you.
Okay. Everyone else, we good? Okay, cool. So I'm going to cancel out. Yes, I definitely want to do that. Okay. So what I'm going to do, and again, let me just double do one quick thing. Let me see if I could send the deck also to everyone now. Yeah. Hopefully you have it now. Okay. Does everyone have it? Or did you guys see the PPT that's been sent to everyone?
Yeah, we got it on the chat.
Okay, cool. Thank you. Thank you. Okay, perfect. Perfect. Okay. So what we're going to be doing now is we're going to play with Python itself. Okay. Now, here's the thing, and I say this out of personal experience. All right. Once you start coding, you're going to make errors galore. I have had days, for those of you that have me, especially this semester, how I say I have my therapy cats, you will get frustrated. It's fine. Okay. If you join us on this journey, it's okay to make mistakes. This is one of the few times that, look, a mistake is not going to hurt you. Okay. When you open Jupyter, you are going to see something called localhost 48/tree. Ignore what that means. It's just saying this instance of Python is yours and yours alone. No one has access to it. Okay. You will see potentially these directories. It's perfectly fine. Okay. Some you won't. Now, I already built a file here, but we're going to start from scratch. Okay. In order to start from scratch, what we're going to do is we're going to click on this button right here, new. It's going to open up a little sub menu. I want everyone, and again, if you have it installed, great. If you don't, it's okay. Click on Python 3. What this is going to do is it's to open up a Remember how I was saying that when we typed in a comment and we just kicked it off and we saw that little part? This is what it's doing. It's saying, oh, here is my server, I'm constructing it, access to my notebook, this is my user info, blah, 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 blah. Perfectly fine. Okay. Never close this window, all right, while you're coding. Just leave it on in the background. Okay. Just leave it. It's not an issue. Now, here's the thing about Python. Okay. Python is composed of libraries. Okay. And these prepackaged functions. But what it can also do is you could do some basic variables. You could do some basic analysis without libraries. Let me give you some more info to it. For example, one thing that Python likes to do and what is considered to be good programming. Now, again, this programming, you don't have to be a comp sci major. You don't have to be a CIS major. I was neither, okay? But there are some rules. One thing that we tend to use a lot of is commentary. Commentary in the sense of this piece of code does this. It helps a lot, all right? Typically, or not typically, when we see a piece of code and we want to show what it does, we put in a comment. It's always, and actually, let me increase my screen size so everyone can see it here. When we a hash or a numerical sign starts a comment, okay? What this will do is it does absolutely nothing. Python just says, okay, it's a comment. I don't have to worry about this. Forget it. But we have some other things that we can do. For example, Python instinctively understands the difference between numbers and character variables. So if I say like if I want to create a number variable, all right, I could assign a value to this. Okay. In this case, the way that we do it is, especially in Python, it's the name that you're considering, the name of your variable. So for example, if you're running a regression or what have you, if you're looking at age, that is a specific variable. And we could assign, in this case, let's say how old I am, I'm 38. Okay. Then I could also assign a character. So a variable that is not a number. Okay, that would be, a character. I'm just going to create a random name called character variable. You could call this, here, Miss Polly Prissy Pants, for all I care. It's perfectly fine as long as you understand what the character is going to be. So I'll just go back to character variable. But here's the thing, character variables have to be denoted by single quotes. Now, I'm going to hit enter. Nothing has happened yet. Python doesn't see anything. It's just saying, I see data. I just created a temporary file. I'm not doing anything yet, okay? I want to print this information. Well, I'm going to play with it, okay? I want to combine my character and my number variable. The way that we would do this is the following. We could say, combine stuff, right? And what I can do, and there are a lot of different ways that we can do this. One way is to say, we're going to create a string. In other words, we're just going to make sure that all the characters, this new variable, is just characters, no numbers, nothing like that, okay, is going to be, in this case, my character variable, or let's say actually my number variable, okay? And I'm going to put in a space. I could say plus. And now here's the thing. We're creating a new variable. Here, we could put in a quote. Jupyter will put in both for you, okay? Now again, what we're doing here is well, I don't like to call it simple. The first time we do this, it is freaky. So if you feel overwhelmed, it's okay. No worries about it. It takes time to get used to it, okay? And that's the other thing. If you have questions about it, what have you, that's why we're here, right? That's why we're here. Now, I'm going to also combine it with my character variable, okay? I'm going to hit enter. Nothing has happened yet, okay? We're just defining things really easily. And I put that easily again in quotes. In order to show what we have, we're going to type in print, open paren, and I'm going to say combine stuff. This is a very important thing. When I hit this, okay, nothing has happened just yet. These are commands. It's not telling Python to do anything. In order for this to run, to execute, we have to click that little button right there. I'm going to kick it off, and it's going to say, oh, I already made a mistake. I did SF twice. Fine. And notice what I did. I made a really silly mistake. I did number variable and number variable. So let's change this to car variable. Okay. I'm going to replace it. And I'm going to run this again. There we go. 38 space SF. Glorious. Okay. We have the ability, and here's the nice part, is that, you know, let's say you make a mistake or what have you, you don't have to copy this again. You could go right back into this root directory, and you could just say print, let's say, the number variable. Click. And now we're going to see two instances. It's going to say here's print, and here's another print command. Okay. How's everyone holding up so far?
So far,
Okay, so far?
Yeah.
Sure?
Yeah.
Okay. Now, again, I mean, it's being recorded, so all of you will have access to this. But this is kind of like the basic structure, right? What I want to do now is do something kind of, I won't say overkill, that's a little scary, but something that's more applicable to us, okay? Something that's more, quote, real world, right? And rather than just going through like some of the I don't want to say the sillier stuff, but let's do something that actually is common. So what we're going to do is, and I'm going to send out a file to everyone. Where are you? Bear with me one moment, and let's see, get my Python. And, okay, so everyone, you're going to be getting a very tiny file. And in this tiny little file, come here, come on, where are you? You just make sure here. It's a very small file from the US Census, okay? Now, I'm going to show you what this file looks like. This is it, okay? I just pulled something small, right? Python can do things that Excel can't. One of the big things that Python can do is they could work with obscenely large data files, millions of records, millions of variables. So this is the file that we're going to be playing with. It's going to say label US, you know, exclamation point, estimate, United States, exclamation point, percent. Great. Now, I'm going to close this sucker, and I'm going to go back to Python. What we are going to do, let's say, what we are going to do is we're going to import some libraries and packages. So far, these packages I'm about to throw in are the most common. Okay, I wrote here what they do. NumPy is a very, very important package in Python. It does a lot of basic calculations. SciPy is one of my personal favorites because it does statistics for you. Matplotlib, it's a plotting package. And I'm going to load the entire package, and I'm also going to load a very specific package called PyPlot. I'm going to load something called pandas. This is a data frame that allows data manipulation. We'll go through it, so don't worry. Seaborn and Bokeh are really cool visualization packages. And then sklearn, which is going to be something that deals with AI and machine learning. Okay. If you've not seen or heard of these before, no worries. What we are doing is instructing Python to go through Anaconda, pull these libraries onto our machines, and say, and we're going to create what we call an alias. The reason why we create these aliases is that it's easier to type. You will see what I mean when we start playing with this, okay? When we do this, and if I click run right, nothing, absolutely nothing is going to happen, all right? It's just going to go into Python and say, okay, I'm going to refresh, nothing has happened, done. Okay, cool. Now, let's load this data into Python, okay? In order to load the data, all right, we type in the following. Here's the thing with everyone. I'm loading it from my local directory. This is going to be your path right here, okay? It has to be between 1 ticks, okay? What we are doing here is the following. We're saying that our census data, this is the structure, the variable that's going to house this information, is saying PD, that means I'm going to go into pandas, that library, and I'm going to use this command, read underscore CSV, okay? Because this file is a CSV. Okay? Now, it's going to say, read the CSV in this directory. I'm going to say that header equals 0 means use the default function for the header. You'll see what I mean when we look at the data. And NA values, these are null values. If we see any null values, I'm labeling as negative 999. Okay. What I'm going to do is I'm going to then, just for giggles, I'm going to print the data to make sure that it loaded properly. Okay. So it's going to be print, open parent, census data, close parent. I'm going to click run. And here we go. Okay. Notice you're going to see this 0 through 17. This is called your index. Okay. Python reads everything from a 0 point. So your first variable, okay, has an index of 0, both for columns and for rows. Okay. We'll this later as we play with it. But now here's my problem. I really, really hate this label United States exclamation point United. It's not pretty. I'm already having problems with it. It's giving me anxiety. I don't like it. So I'm going to rename these labels. Okay. We have those functions. All right. So what we could do, and this is where where Python has a bit extra power relative to Excel, is imagine you have the same thing over and over. You have multiple tabs in Excel. You would have to type it all the way in, etc. It's just a pain. And we've all made the mistake of that fat finger error when instead of saying hi, it's either who or whatever. This helps cut down on those mistakes. So how do we rename this? Okay. Well, renaming column headers, and again, I will share this code with everyone. Okay. We do the following. We're going to say census data. So in other words, I'm updating this file by going into the file, okay, renaming the columns, okay, and this is a bracket, so it's not the square bracket, but rather the curly bracket, okay, and I'm going to put in the name of these headers. It's going to be label. This is the original, and I'm changing it to age underscore group. I like to use the underscore just so that it's, for me, it's easier than a space. Okay. And I'm saying United States estimate, I'm saying estimated count. United States percent, I'm using percent. I could confirm this easily by, again, going through the print command and saying US Census data. When I do this, note it's now changed. And notice how quickly that went. Now, there is what we are going to do next is something that is considered to be best practices. We are going to take this data and put it into a format that we are comfortable with, and also Python is very comfortable with, and that is called a data frame. Think of a data frame as a type of Excel spreadsheet, okay? See, up until now, what we have done is we just loaded data so we could print it. Great, but a lot of times what are we going to be doing? Modifying the data. The last thing we want to do is screw up our raw data. A data frame is kind of like a copy of our raw data. All right, I'm bastardizing the definition a tad, but that's what we look at it as. And we're going to create a data frame called census df using pandas again. Again, pandas being this data frame package that allows us to manipulate the data. It's going to always be pd.dataframe, that's the command. And then it's going to be open paren, close paren, census data. Okay. Now, once I do this, again, it hasn't executed. I have to click this run button. But I want to see what is in this data, right? So what we're going to do is we're going to check the data types, okay? Now, when we check the data types, this is the reason why we do this. We've all played with Excel. We open up Excel, and when we go into the format column, we see what? The cell is general, or the cell is text, or whatever the heck it is. And we've all, if you have played with Excel, sometimes we have a problem. Is if you want to combine cells or columns together, we're going to get an error. And we say, we scratch our heads, we don't know what it is. The reason is because we have different data types. Now we're going to say the following. We're going to print the data frame, and this .d types, that is the command to say display my data types. This print two single quotes is going to put in an extra space. You'll see what I'm saying in a moment. Okay, I run, and notice what happens. It says age group is an object. You don't have to worry too much about what this means. The estimated group or estimated count is an integer or a number. The percent is a float because we have multiple decimal points. Now, am I done yet? Oh, of course not. All right. We could play and create some summary data. Okay. What we're going to play with here is let's print the sum of, let's say, the estimated count column. Let's take the average. Let's take the standard deviation. Okay. So those, and we're going to put in a label. All right. What we're going to do here is the following. Now we're going to start showing some data. Okay. We're going to print the entire data frame, so everything that we saw originally. I'm going to put in a space just to make the results look cleaner. And what I'm going to say is I want to print, and when you see this, the single quote, total sum of estimated count, colon, space, single tick, and then a comma, I'm going to say I want you to use this string. I'm going to just say display this, and then give me the sum. All right, so go into my data frame, go into the specific column called estimated count, and give me the sum. And we need to have that open paren, close paren. Okay. We do the same thing with the average. Again, go into the data frame, go into that specific column, and give me the average. In this case, it's labeled as mean. In Excel, it's average. Here, standard deviation. Again, we've all, if you remember basic stats, it's a pain because you have to keep, get the average. Then you have to, subtract it from that data point and blah, 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 blah. Why do that? Let Python do it for us. And we're going to run. Okay. Now here's the thing that we're going to see. We saw the data, we see the data types, boom. That space is giving us this command. The print, we see all of this, age, group, estimated count, percent. Here, if we go down a little bit, we're going to see the total sum, total average, I'm sorry, the average, and the standard deviation of everything in this column. Now, I have a problem, all right? Right off the bat, I'm like, oh, this is awesome, this is cool, great. Wait a minute. I already have under 5, 9, 14, 19, blah, 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 and I also already have this information grouped. So I'm mixing and matching. I have a problem with my data. Believe it or not, and this is the thing about data science and a lot of this stuff, and is data science is a lot of data cleaning, understanding your information. The more you understand the data, the sharper, the faster you will say, oh, this is the information I need. The question that we have is useless until we clean our data. So I don't like this. It's shoddy. It's making me sad. So what I'm going to do is I'm going to say, I'm just going to focus on, let's say, under 5 through 84. Okay. So what I'm going to do is I'm going to go back up into this window. Okay. And I'm going to pull out data from my original data frame. So think of it this way, we load our data, then we clean up our data into that Excel spreadsheet. Now the next thing we're going to do is we're going to, instead of doing the copy paste and moving it to another spreadsheet, we are going to create a new data frame. Okay. Well, the way we're going to do that is I just want to focus on the age group, okay? And in this case, what I'm going to have to do is twofold. When I do this, I'm going to print it, okay? And you'll notice I'm looking at column 0 through, or index 0 through 12. So I'm going to be looking at this data. This 12, all right, is what we would call exclusive. It does not count the 85 and over. I'm just going to be counting up to 11. I'm going to run this, okay? So I create my age group equals, and I'm taking it from my census data frame, so what I had created up here. And I'm going to look at this index location, okay? So it's taking all the data from 0 all the way through technically 11. And I'm going to print it. And here we go. Notice that we got rid of the 85 and over, the 16 and over, all this stuff, okay? And I have a nice, cleaner data set, okay? Just for giggles, let's delete the percent, just for giggles, okay? Like with, for example, and when we've always had that momentary fear when we accidentally hit the delete button in a, let's say our own directories, and it disappears. Here's the problem with Python. Once you hit that sucker, once you execute it, it's gone. You have to get rid of it. You have to, quote, comment it out. What this is going to do is it's going to say delete this object, this column rather, in the age group data frame called percent. We're going to print it just for sanity check, okay? So notice what we're doing. We have our objects, our original data, stuff that is somewhat useless for us because the data is over estimated. We're starting to clean up our information, and we have the stuff that we're going to be playing with. So up until now, we're playing with the data. Let's now calculate, just for giggles, the z-score, all right, for each of these groups, okay? Now again, if you remember your stats, what's the z-score? The z-score is that specific data point minus the average divided by what? The standard deviation. It's a pain. We don't need to worry about that again, because in our packages, the stats package, or specifically the SciPy package, okay, we have a standard deviation and a z-score function that does it for us. And it's already in there. And when I run this thing, again, I have not shown anything. So let's print this. And here's something that Python, we always have to worry about. We're going to say print z-scores. It's going to put it into what we call an array. Now, here's the thing. It makes sense. Well, not makes sense. It's commonplace. This value corresponds to this data point. This last value corresponds to this data point. Great, lovely, wonderful. I want to let's merge it back into the original file. Okay. Well, in order to do this, we have to create a separate data frame, if you will, that houses the z-scores. Okay. So I'm going to create a z-score data frame. Right, so like a placeholder, if you will. It's going to say, I want to create a data frame based off of this information, and I want the column to be called z-score. Okay. Then what I'm going to do is I'm going to create a summary table. right, called summary census DF. What it's going to do is it's going to say, take the original that I had, right, the age group, so this one, and join it with the results from here. And I'm going to print it, right? This will run, and now notice what we have. Age group, the estimated count, and the z-score, all in one. Now let's do some basic graphing, super basic, okay? Now, in order to do this, right, we are going to be using the matplotlib library, specifically pyplot, this PLT, okay? Now, pyplot has some built-in commands, okay? First off, if you do plt.bar, that means we're going to create a bar chart. And it's going to be, we're going to use the census data, or the summary census that we have here, so that summary table. We're going to look at it from the age group, and then we're also going to use the estimated count, okay? Just for giggles. I have to put in my x-axis label. It's always plt.xlabel, open paren, single tick, the name, single tick, close paren. And I want to rotate the so the lettering to be 90 degrees. We've all seen it sometimes when we have, for example, in Excel, you know, it kind of looks garbled if we create a chart. I don't like it. It's not clean. So let's just rotate it 90 degrees. My Y label is going to be estimated or estimate a US population count. And my title is going to be US Census population count by age group. Here's the thing that we need to do. If we don't have this command, plt.show, that means that, guess what? We're not going to show the graph. Okay. So if I run this, we see this progression. And again, this is due to the print commands. Keep going, and then here we go. We have an estimated population count, all right, in the, what was that, millions, census, etc. We could also change this by color if we wanted to, the full gamut. But again, it's a lot of data. It's a lot of commands. Now, here's the thing. I'm done with this demo. It's a lot of info. It's a lot. But again, this is something that Best is definitely going to be playing with next semester. And we're going to be learning Python together. We're going to be playing with this stuff together. And I personally, you know, hope all of you will attend those sessions. I'll be the one kind of doing some of these demos. Hopefully some of the other members will be able to kind of help out here and there. And we could play with it as we see and as we go forth. But that's that. You know, I conclude this thing. So Louis, I'll give it back to you, and then you know, we could call it.
Okay. Well, thank you for joining, everyone. Thank you, Dr. Sandor.
Don't worry about it. No worries.
Yeah, we're gonna try to next semester. We're gonna try to do a lot more with Python, and we're gonna be looking at data, and we're hoping that we're gonna have kind of like a mix of Dr. Ferenz doing some of it, and then also some of our club members doing it as well, whoever feels proficient enough, and they'll be leading these, I guess, like kind of like intros and more detailed look at Python and how we're going to hopefully use that with when we actually graduate and maybe get into work as well. So thank you again, everyone, for joining. We are going to probably post this up. We're